Hi. For the video today, I wanted to go through pressure conversions with you. I've got the homework packet here for pre-AP. I've got the front of the homework packet here with the pressure conversions on it. Pressure conversions are always given to you for my class, so you don't have to worry about memorizing these. You just need to know how to set them up using a dimensional analysis problem. Looking through the different pressure conversions, just to make them a little bit larger, you've got PA, which is Pascal. Torr is torselli. kPa, Pascal is a base unit in the metric system. So kPa is kilopascal. PSI is what we use here in the United States for most of everything. It's pounds per square inch. So if you have a tire of your car or anything like that, it's all going to be done in PSI. You have millimeters of mercury. That's what Mr. Torselli used to make that first barometer. He measured the millimeters of mercury in the column. And then ATM is atmospheres. Typically what we do in chemistry is done in atmospheres, which is why all of your pressure conversions all take you down to atmospheres, because we need to get to that unit very quickly. When we get to the gas laws unit, next unit, we're going to have to convert it out to atmospheres in order to do those problems. So looking at your problems, you have 1 step and 2 step. Nothing in this class will be more than 2 steps for your pressure conversions. This first one says that we have 109 kPa and we need to take that to ATM. So we have 109 kPa. We're going to convert it out using the conversion factors. So if I get my conversion factors here, it says that there are 101.3 kPa in 1 ATM. So I'm going to take 101.3 kPa is equal to 1 ATM. Then I'm going to get out my calculator. When I get my calculator here, I'm going to take this and go 109 divided by 101.3. I have 3 sig figs to start here, so my answer needs to have 3 sig figs in the end, 1.08 ATM. To show you a little bit larger problem, something with a couple steps, we're going to need to go down to number 8 on this paper. Let me move this up. Sorry, a little awkward there. For number 8, we have 43.2 psi, and we need to go to kPa. So if we have 43.2 psi, we're going to start with that number. You always start with the number that's given. For our conversion factors, we don't have anything that goes straight from psi to kPa. So what we're going to have to do with this is we're going to have to make sure that we go from PSI to ATM. And then once I go from PSI to ATM, then I can go from atmospheres, ATM, into kPa. So my conversion factor says that there's 14.7 PSI for every 1 ATM. PSI on top and bottom cancels. That has now changed it to ATM. Now my second conversion factor says 1 atmosphere, ATM, is equal to my 101.3 kPa. Because I have atmospheres on top and bottom, it cancels. So now to do the math, I'm going to take my 43.2 times 1, which you can skip, times 101.3, divided by the 14.7 would be times 1, but you don't need to worry about that. This number had 3 sig figs to start, so I need 3 sig figs in my answer, 298 kPa.